Hello, I'm here to introduce our program today. This program is a simple mini compiler that processes arithmetic assignment statements, and it contains of three main components: a lexer, a parser, and a syntax tree generator. Here is the syntax tree printing, and the lexer is charged of scans the input and convert character into meaningful tokens such as identifier, integers, operators, and punctuation. And here's for the lexical analysis. And the parser is to check whether the token sequence follows the grammar rules. And now here, if the input is valid, the program construct and print a clear syntax tree. If any lexical or syntax error occur, the program reports them with the exact position. And overall, these two demonstrate the basic workflow of a compiler: tokenization, parsing, and structural analysis. And now I will show you some example. Let's enter expression statement. This one go first. And this test case 1, value expression with parentheses and multiplication. Here's the input. In this case, the lecture correctly products 10 tokens with no lexical errors. During parsing, operator precedence is handled properly. The expression inside parentheses 3 plus 5 is grouped first and then multiplied by 2. The completed syntax tree is generated, clearly showing this hierarchical structure. And then let's go to the second one. This case is value expression with a multi-digit integer. And as we can see, this one is the input. And here the lecture successfully identifies the multi-digit integer 10 as a single int token, and the minus sign as an operator. The parser builds a syntax tree with the subtraction operator as the root and confirming that the entire statement is valid and correctly ends with a semicolon. Let's go to the third one example. And here is test case 3, value expression with nested parentheses. And here's the input. Here's token string. In this example, parentheses are matched correctly and division is evaluated before subtraction. The parser constructs a syntax tree where minus is the root and division A divided by 4 forms the left subtree and 1 is on the right. And here's no lexical or syntax errors occur. So let's go to the case 4. Case 4 is invalid expression due to a lexical error. We can see here's what this one is the input, and this symbol like dollar is not part of our language specification. The Lexer detects this immediately and reports a lexical error at position 6. Here's the exactly position. Because a lexical error exists, the parser is skipped, which matches the program requirement. And then we go to the case 5. Case 5 is invalid expression due to a syntax error. We can see here is the input, and all characters are lexically valid, but the parser finds that the closing parenthesis is missing. During parsing, it reaches the end of the expression and reports syntax error at position 14. This confirms the program's ability to detect incomplete parenthesized expression. And this 5 test case demonstrate that our program correctly tokens valid input, builds syntax tree, and reliable reports both lexical and syntax error. Thank you.